Okay, so anyway, no, the test is not tomorrow. It was at one point it was going to be tomorrow, but it's not. All right. Nope, we're going to start with math. All right, you are going to start with can you find the point -2 comma pi over 6. Find that and put a dot there. And hint, you don't want to start at 2 comma, or sorry, you don't want to start at -2 comma pi over 6. You want to start at regular 2 comma pi over 6. No, I did it on purpose. I want to make sure you didn't try to find -2. That's, no, don't do that. So this is kind of like cotangent or something, or one of those other sister functions where you're like, I'm not going to do the secant. I'm going to do the other one that I'm more used to, but I got to flip it. All right, so this is like that. I'm going to find 2 comma pi over 6 first. And I know that's not the answer, but I'm going to start with that. And that would be, well, it depends on how many circles you want me to draw here, but I could do it that way and say this is 2 comma pi over 6. Pi over 6 meaning about 30 degrees. That'd be about that. But that's not the answer. That kind of helps me get the answer. Now I know that I go straight across from that and it's over there. Raise your hand if you had that one in the right spot. Okay, awesome. Now, can you make that into rectangular? Rectangular means you got to figure out how far over and then how far down to get to that spot. My best way to doing this is say this is X and this is Y. And I like to draw triangles because I've been telling you since the beginning that that'll be really handy on these kinds of things. You draw your triangle, you put in your angles. Ooh, I know this one. It's a 30-degree angle. And I know the 30, 60, 90. I hope you do. Okay. Did you figure out that that side would have to be a, no, that's not a 1, is it? No, this side's the 1. But even better, it's going down 1, so -1. Raise your hand if you figured out that y would be -1. Okay, how about the x? Square root of 3. Do you recognize the 1, 2 square root of 3 triangle in there? And then is that really square root of 3? No, it's negative square root of 3. So the final answer is this point. This was like a helper. The final answer is a rectangular x comma y -√3 comma -1. Should we practice that, or do we not need to practice that? All right, one more like that. I'm getting a lot of one mores. Question first, yes? You would not have to draw the rings. You'd have to label this as 2. So, for instance, if you graphed this and I said it was 6 comma pi over 6, you could just say that that was 6 by going like this, 6. Okay, all right, so try this one. If I told you that I had a point that's in polar of, let me think, here's one you'd know, square root of 2. Well, that seems weird, but it'll be really handy on a triangle if I use the right angle. 5 pi over 4. You please try to figure out what the rectangular would be for that. Always graph it, figure out all the sides, all the angles, and then it won't be that. You see what I did there? All right. There was strategy involved. It's not really a word, but it should be a word. Did you figure out 5 pi over 4 was like that, and therefore we should be going that way? All right. Then, how long is that line? Square root of 2. All right. Now, what do we really want? We want this, and we want this. It's really good to tell me what you want, what you really, really want. I want that side and that side. X and Y. And if I were doing this problem and I had forgotten, or I wanted to be really careful because it's like, dang, if I get another question wrong, I'm probably going to drop another grade, which happens on your tests all the time. People make a dumb mistake they don't even realize. And then they have one other one they're like, oh, I don't know what to do. I would really carefully draw out 1, 1, square root of 2, 45, 45, 90, and I would then set up a little proportion. And I go, y is to 1, y is to 1, like root 2 is to root 2. And that means, oh, that's actually 1, and that's actually y equals 1. Oh, yeah, it is 1, except it doesn't know which direction it's in, so you have to know that's negative 1. And if it's a 45, 45, 90, you should know that that's also negative 1. Negative 1, comma, negative 1. Raise your hand if you had that one right. Okay, good. All right. Now, that was actually from 2 days ago. Yesterday was y equals something, and it had to do with cosine or sine and r. And then there's x equals, and then there was x squared plus y squared. Would you please fill out all 3 of those and tell me what were those little conversion things so that we can use these little equations to convert between polar and rectangular equations. R sine is correct for this top one. What's the bottom one? R cosine. And how about x squared, y squared? R squared. All right. So then a technique would be, you get an equation like r equals 10, and you would be told you need to change that into rectangular, because right now it's in polar. How can I tell it's in polar? Because it only has r's or thetas, and it doesn't have to have both. It doesn't have any x's or y's, so that's in polar. By the way, in case you've forgotten, that is a circle with a radius of 10. It's very easy to graph a circle when you're in polar world. You say r equals 10, and you're saying every angle goes with that. It's kind of like in xy, where you graph x equals 3. It doesn't say this, but it implies no matter what y is, x equals 3, and you get an infinite number of points where y is a million different things, but x is always 3. Same thing here. It doesn't say this, but theta can be a million different things. Theta could be like pi over 6, which would be there. Theta could be pi over 2. Theta could be pi. Theta could be 3 pi over 2. Theta could be 5 pi over 4. And you just keep graphing every possible theta, and you get a circle. Okay? So, how would you actually do this question? I just want you to understand what it was. Here's what you do. You square both sides, and it becomes super simple, because what's r squared equal to? Yeah, that. So I'm going to replace r squared with x squared plus y squared equals 10 squared. And why is that better? Because it only has x's and y's. All right, let's do another one. Let's say we had r cosine theta plus 1 equals r squared. There. Convert to rectangular. BL, do you see anything up there that you can pull out and replace with something else? All right. R cosine theta could be replaced with what? And sometimes kids will like write an answer like that on their test. Why can't I give them credit? Because it's not in rectangular. And it's not in polar. It's in both. It's still kind of in between mode. So, okay, yes, well, it's like a human-pig combo, like a chimera. All right, but this r squared could quickly be replaced with what? Yeah. So now I have x plus 1 equals x squared plus y squared. And it'll even say right on the test, you do not have to solve for y. So we don't have to rearrange this whole thing and do some fancy stuff to it. The hard part is just knowing what to do. All right, so what if it said r equals, let me think, 6 over r There. On this one, hint, you don't want to square both sides. RW. You with me? All right. I'll come back to you in a second. Do you know what to do if I'm not squaring? Multiply by r on both sides. Awesome. Okay. And it's still kind of like squaring, but it's different. If I multiply by r, can I just pick one of these two to multiply by r? I think you know by that question that obviously you can't just pick one and multiply it by r. You have to multiply both of them by r. I could either do this, or it's probably a little faster to just distribute the r out right off the bat and go like that. What's kind of nice about that one? It just cancels and it's just 6. Yep. That one's nice because that's r squared, and I know what that can convert to. X squared plus y squared equals 6 plus, what's that one? X. That's only got x's and y's, so it's rectangular. All right, there's a quick review of yesterday. Now how about today? Today you got two basic kinds that I want to make sure you understand. If you had to solve this system, you could just substitute wherever y is. You could put 9 plus x. You get what I'm doing there? I can just replace this y with 9 plus x. That's called substitution. If I was solving this equation, and I had do you get? I can use substitution. It's a system of two equations. If r really is 7, do you get then? I can put a 7 here and I can put a 7 here. And this is times. So then this is 7 equals 21 cosine theta. And people are like, how is that solved? It's not. You'd have to get theta alone. So first step, look to add or subtract anything from both sides. Can't do anything like that. Could you multiply or divide by something to try to get theta alone? What? Not 7. Try again. 21. 21. Cancels. 21 and 7 makes 1/3 equals cosine theta. Now I happen to use one that's kind of nasty because you don't have this one memorized. Okay? But could you still give the answer? Yes, you could. Would you please draw the triangles in the right quadrants and tell me what both answers are? But I'm warning you, you're going to want to give answers with inverse tangent or inverse cosine or inverse, you want to inverse something because your angles aren't one you have memorized. You don't know this one. It's not like, oh, it's 30 degrees. You aren't going to know it. So you got to give your answer as an arc, whatever. If you don't understand what I mean, draw the triangles, label all the sides, and your answers aren't ones you have memorized. So you have to say inverse tan or inverse cosine or just you are going to say arc cosine in a moment. But isn't there more than one answer? Now, let me tell you why there should be more than one answer. Just think about this for a second. Do you get that that's a circle? R equals 7. It's a circle. If I graph this one, I think you're going to have to take my word for it, but it's a circle. If you have two circles and they overlap, like let's say one of my answers looks like this. Let's say that my other answer looks like this. Did you get when you have two circles, they cross twice? Is it possible two circles could never cross? That would mean no solutions. What happens if I have two circles that only touch once? They just overlap at that one spot. Then they only have one answer. So you could have one answer, two answers, or no answers when you have two circles. They could be the same exact graph if they overlap everywhere. That's true. But we aren't going to do that to you. It's a good point, though. All right, so my point is, it feels like to me that there should be two answers to this. Let's see. Did you realize that cosine, first of all, There is no inverse in this problem. This doesn't say inverse cosine anywhere, does it? Okay. Then that means we don't have those restrictions. We just want where cosine is positive. Oh, students, take calc. Cosine's positive over here. So these are out and this is out. Now, let's label our sides. Well, wait a minute. And I know cosine's positive too. Right? Oh, wait. So that still could be either spot. All right. So now I can go like this. Cosine's adjacent over hypotenuse. And this side must be square root of, don't say 2. It's not. What is it? It's 3 squared and 1 squared. And should I add them or subtract them? Subtract them. So that's going to be square root of what? 8. Very good. That's a square root of 8 over there. And yeah, there's another one down here. I know this is a little bit confusing, but one thing at a time. We're going to just get the answer for the red one first. Yes? I'm going to get there right now. I'm going to say, how do I say this angle? Because I don't know what that angle is. I never memorized the 1, 3 square root 8 triangle. Okay, so if I had, I'd be able to say, oh, the answer is like 12 degrees or whatever, but I haven't got this memorized. So I can say that the point is the radius. Do you see the radius of this? 3. And then, wait a minute. Nope. No, I'm misleading you on that. We already knew the radius from up here. Remember R was 7 in the problem? Okay, so my answer is where these two cross is going to be 7 comma something. And it's that angle. How am I going to say that angle? Inverse tan, tela, opposite, over adjacent, square root of 8 over 1, but that would be the same as the square root of 8. I'll put it there maybe because it'll help you understand it better. So where is the point where those two lines intersect? They intersect at 7, comma, and this is r comma theta, 7 comma, and if I just knew the angle, it'd be awesome, but I don't, so I have to put that. So it's 7 comma inverse tan of root 8 over 1. Can you think of any way I could give the other answer for that? But yes, first question. Inverse tan can't touch here, and it can't touch here, but inverse tan can be in there. Remember how inverse tan was a lot? You're right that inverse tan doesn't touch, but it doesn't touch up there and down there. So it gets really close, but doesn't touch those spots. So if I thought the answer was pi over 2 or negative pi over 2, then it wouldn't work. And what that would mean is that there's no solution. Okay, I know this got really intense. Don't worry. This is one of the reasons the test is not tomorrow. Don't worry. We got time. I'll teach you more tomorrow. You get a little bit smarter. All right, so one thing at a time. I'm going to see about, can you do, if I have an equation that looked like this and an equation that looked like this, would they cross? Yeah. So is there a solution to the system of equations? Yeah. There'd actually be 2 spots that they would cross. Remember, if we're in polar world, that spot right there is something like, 3 comma pi over 3 or something like that. And the question is, where is that spot? That's the hardest kind. All right. I think the next part is you got to see how to graph. So I'm just going to next go to the graphing part. So I know if I see this, I know how to graph that. And I go, oh, I know where that is, and I know what it looks like. But you don't. And that's okay. I'm going to start with probably the easiest one. Let's graph r equals sine theta together. Everybody write this one down. And what's your best friend in graphing? XY chart. Do we have an X and a Y? No, not unless we do something complicated like multiply both sides by r, and then if I do that, I'd have r sine theta, and then that's, ooh, that is something. What is r sine theta? If I multiply both sides by r, that's y, and then that's r squared, and then it's like x squared plus y squared equals just y. So that's kind of a weird circle. Do you get that's kind of a circle though? Because it's got x squared plus y squared in it. Guess what? The answer for this is going to be a circle. All right, but we're going to go back and do it a different way. We're not going to multiply both sides by r and change it into a rectangular. We're going to keep it as a polar. We're going to graph it as, instead of an xy chart, I'm going to have a r theta chart. Everybody get that written down. Now, if I told you, okay, here, I'll give you 3 points. Graph the circle for me. If I tell you, here's 3 points. Do you know for sure what the circle looks like? Oh, no. It'd be hard to figure out if it's like, I think it's kind of like that. Maybe you'd have a chance with 3 points. With 2 points, you would have no chance. Do you get if I gave you like 9 points? It'd be extremely easy to see where the circle is. Do you get what I'm saying? So for these, you're going to have to give, and in fact, I think on the test, we typically ask you for at least 6 points that you'd have to graph. All right, so since I have to find a whole bunch of points for this, what are some of the best ones to pick? Well, things that are easy to do sine of. Do you like doing sine of 43 degrees? Probably not. How about sine of, what's a good easy one? 30 works. And how about 0? Isn't sine of 0 something you could do? Sine of 30, sine of 60, sine of 90. Oh, I skipped one in there. What's one in between 30 and 60? That's easy. 45 and 60 and 90. And honestly, if you just went up by 30s and did every single one of those, 30, 60, 90, 120, 150, 180, you got what I'm saying? You could do all of those. It wouldn't be that bad. But I want to give you a smattering like this. Maybe we'll do a few of those 30s. This will be 120. All right, next thing is, I'm kind of cheating by using 30s, 60s, 45s, because I really should be using radians. So what are the radians for these things? 0 is still 0. What's 30? 5 over 6. What's 45? 5 over 4. How about 60? Pi over 3. How about 90? Pi over 2. Have you ever noticed that? 6, 4, 3, 2. The only one never uses pi over 5. All right. And then this 120. Ooh, that's kind of a weird one. I'd like to think of it this way. 1 pi over 6. 2 pi over 6. 3 pi over 6. And 4 pi over 6. And that reduces to 2 pi over 3. Or 4 pi over 6 would have been fine. Okay, and now, what is the actual answer, server? Well, you gotta figure out what's sine of 30. And then you put it in. Hey, we just came up with the 34th time that I've asked you for the sine of 30. What is it? 1/2. All right, yay. See, you learned something out of all this trick. Sine of 30 is 1/2. Yay. Okay, and yeah, 1/2 comma 0 is something you should be able to graph, though, isn't it? If that's 1/2, r equals 1/2. All the r's aren't going to be the same. Okay. All right, so sine of, and I'm confusing myself because I put the 1/2 in the wrong spot. I apologize. It should be down here. I just did 30 degrees. Sine of 30 is 1/2. So there, at 30 degrees, it should be 1/2. Would you agree that's about 30 degrees? Okay, and I'm going to say that this distance, I'm going to define this distance as 1/2. There, got my first dot. All right, let's do some more. How about sine of 45? I'm going to give you a hint. It would be really handy if you had all of these memorized, 30, 60, 90, 1, 2, square root of 3, I think you have that one, don't you? Do you get that that would give you sine, cosine, and tangent of 30 and 60? You can't do tangent of 90 from this, though, right? You can't do 90s. But what can you do 90s with? You can get 90 and 180 and 270. You can get all of those from these spots. I know you're tired. Oh, still poke them. All right, yes. I need this spot, which is what comma what? Let's see, 1 comma 0. How about this spot? 0 comma 1. How about this spot? Come on, what's this spot? Negative 1, 0. And how about this spot? 0 and negative 1. Why did I do all those? Because that'll tell you sine, cosine, and tangent of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Did that come up in one of these? Yeah. We needed 90. And we can now do sine of 90 from that picture. And then the last picture is this one. 1, 1, square root of 2. 45, 45, 90, there. Now you have every tool you need to answer every one of these questions. 120 is a little weird, but if you draw the picture, you say, oh, this is where 120 would be. Then you should be able to go, oh, so that's a 60. Then it can make a total of 180. And really, you got a triangle like this when you have your 120-degree angle. You should be able to still get me sine of every one of these. This is going to be one of the harder questions on the test. Try to finish and give me answers for this, 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 and this. They're all in the little pictures that I just drew right there. Okay? Find sine of 0, sine of 45, sine of 60, sine of 90, sine of 120. Yes, sir. What form of pi over 4? Oh, I got you. I don't care. I'm okay. I think most people are going to use this one because that's the way we memorize the triangle. But, okay, find the answers that are in the little Easter eggs here, little circles. All right, I'm going to pause for a second while you try that. Okay, so let's get some Dice of Destiny. Which answer do you get to do? Row 1. And it is the last person. Katya, I can say first names on here. What did you get for the top one? Sine of 0. Okay, I'll help you. Here's where 0 degrees is. Do you remember that the sine is the y of it? So it is just 0. You are correct. So 0 and 0. Now don't think of this like x, y coordinates. This is a radius of 0. Oh, right away. I don't even care what the angle is. If the radius is 0, do you know where we are? All right. So we're supposed to be graphing these things. I got the first one graphed here, and then I started writing on it. So I'm just going to delete this stuff. There. 0, 0. There's a dot here. There's a dot there. Do you know where your circle is yet? You can't tell. All right, we need a few more dots, and then we can kind of tell where our circle is. We know the answer is a circle, because when we substituted it for, like, rectangular, we had x squared and y squared in it. All right, you, sir. The guy with the headphones. Is 45? Can you do sine of pi over 4? I know you can. What do you think it is? Hint? Use this. And I'm disappointed that I'm still waiting for the answer. Come on. Sine of that. You can do this. Close. That's not. There you go. Say it one more time. 1 over square root of 2. Awesome. And I'm going to give you a tip. You are not going to have a calculator for this, and you'll have to know where 1 over square root of 2 is as a decimal. What? Yeah. So let me tell you 2 decimals you're going to come up. Take a wild guess. Other than square root of 2, what's the other decimal you ought to memorize? Square root of 3, because they come up all the time, right? Because of the 1, 2, square root of 3 triangle. So this one, square root of 3. What's your gut? Are we talking like 0.2? Do you think it's, oh, 1 point something? Good. Okay. Well, anybody want to take a shot at what it exactly is? No, it's not 3.14. Come on. All right. Everybody use your calculator for just a second. Be better if you did it and then somebody else did it. You can use your iPad's calculator. That would work. Find square root of 2 and square root of 3 and memorize them. You're going to need them. How many digits? Good question. If you tell me it's like 1.6, that's good enough. I know. You'll have to deal with that. You'll have to figure that out. I know. It's painful, but that's one of the things that makes this hard. It is not a partner test. No. You're going to have to use your own brain and only your own brain. Unless you get good at mind control. That'd be powerful. Nope. All right. What is the square root of 2, sir? 1.4. What is the square root of 3, ma'am? Didn't get it? Over there. 1.7. All right, then, if you have those two memorized, you have a much better chance now of being able to figure out what the heck 1 over 1.2 is. If you were to say 1 over 1.2 is a lot like 1 over 1.5, because 1.4 is like about 1.5, if I had to, I could figure out 1 over 1.5 is like 1 over 3 over 2, which is like 2/3, which is like 0.6. Would you at least have known it was a decimal that was less than 1? Okay, if not, you better work on that. All right, so do you get how I did that? That's not guessing. That's using logic. You can do that just as well as I can. So this is about 2/3. This is about 0.6. And so at a 45-degree angle, it's about 0.6. Here's a 45-degree angle. It's about 0.6. It's just a little farther out. Do you get having a bunch of points is going to make it easier to see where the circle is? All right. Here's another one. Wouldn't it be good to know what it was going straight up and then see where the dot is then? What is that one? What's the one that goes straight up and has a dot somewhere up there? Pi over 2. That's 90. Yeah. What is the sine of 90? 1. All right. When you're all done, you will find it looks something like that. I want to prove it to you because you need this eventually. We're going to do a little moment for your calculator. Grab your graphing calculator and type in mode area, get into polar mode. You've probably owned this calculator for, I don't know, maybe it's been in your family for 10 years. Maybe you've owned it for 3, but you've probably never been in polar mode. Hold on. We're just graphing r equals sine theta. So if I go to y equals, it just says y equals. It's because I'm not in the right mode. I got to go to polar mode. Go to mode, 12-minute warning. All right, so if I go to polar mode, enter. Now I say y equals, and then you just put in sine. I'm going to clear this one out. Y equals sine theta, or sorry, r equals sine theta, and you hit graph. Look at that. Now mine might look prettier than yours because I zoomed in on it a little bit. I don't think it's zoom 9. I think it's zoom 0 you're thinking of, I think. Let me try zoom 0 once and see if it works nice. Ooh, look at that. But again, it can look kind of eggy shaped. Go ahead. All right. if it looks kind of egg-shaped, it's okay. If yours looked a little bit egg-shaped on the test, it's okay. I don't expect your decimals to be perfect. This is going to be a little bit painful to do without a calculator. That's why I spent so much time on it, because how'd you do it? First of all, are you in polar mode?
Yes.
Okay. Then go to y equals. Then does it say r equals at the top of the screen? Now you're going to type in sine theta. And then hit graph. Okay. By the way, I'd want you to know what the big ones look like. Sine, it looks like a golf ball sitting on top of the XY, all ready to be hit. I'm going to hit zoom square just to like, I hope it'll look a little more, yeah, that's a nice circle. What if I zoom out once just to like get a feeling for the bigger picture and what it looks like if I zoom out? Okay, so that's what sine looks like. Now put cosine on there as the second R. Cosine of theta. Graph. Ooh, cosine's a little circle. It's to the right. Yes. Issues? I'm going to pause for a second. Okay. The only thing I'd be able to do for you would be to clear your calculator and then get you to, you know, like this is one of those ones. If you got any weird modes going on in your calculator, it'll mess it up. So if you wipe your calculator back with the second plus 712 key sequence, it'll wipe any programs that you have. But if you don't have any programs or you don't care about that, second plus 712, get your calculator back to factory new, and then it'll graph like this. Okay, so there. Which one's sine? It's the blue one. Which one's cosine? It's the red one. Now, do you get that you can't just memorize that and therefore know what the answer is? No, you can't know exactly where the answer is. But if I know my question is, graph this, r equals 3 sine theta, do you get I know it's going to be a circle? And I know it's going to be generally up here. But then what did the r get? Did the r get bigger when I did times by 3? Do you get the idea? So I better be looking for a circle generally up there. Okay? What if this was a cosine question? Well, then generally it better be a circle that's kind of over there, except the 3 would make it times b, 3 times bigger. You should have an idea where it is, and then you find a bunch of dots. And if you have a bunch of dots and they're kind of gathering around here, you'll be like, oh yeah, I get it. It's a circle. It's going around the right side there. All right. So, your homework for tonight. Pause for a second while we get there. Everybody get there. Okay. It says assignment, day 1. Have you found that page yet? All right. So here's the ones I want you to do. This one's kind of cool looking, but it says use calc. So there's no way you'd have done this one by hand. Okay, so we're taking that one out. Because on the test you aren't going to have a calculator, and therefore we'll just do the kind that you can do with without a calc. I would do this one. That's the very first problem. And I gave you an example of some of the things that you know how to do. Remember, you can get these from the classic right triangles or the quadrantals. Give you a whole bunch of them. Like anytime you want 90 or 180 or 270, 3 pi over 2. If you want this and it's at 0, -1, you can tell the sine, the cosine, and the tangent all from that little picture. So use the 30, 60, 90 triangle like this, use this picture, and use the 45, 45, 90, and you'll be able to get all of these answers. And also, who's got a short-term memory? Square root of 2 was about what? Square root of 3? Very good. There you go. If you can keep those two memorized, you'll be able to like kind of estimate where that dot should be. I totally get some of you are going to be off a little bit. If you're way off, you won't get the points. So try to be as close as you can. But I know the square root of 3 is 1.7, so this first one is 1.7 for a 30-degree angle. Why? Because we don't forget you times by 2. So it's cosine of 30. And cosine of 30 is not 1/2. Cosine of 30 is root 3 over 2. And then you times by 2. And that's why it's just root 3. And root 3 is about 1.7. So if you want to put the very first dot on there, it'd be this is 30 degrees, and this is 60, and this is 90. Then at 30 degrees, I go out 1.7, which I'm going to say is about there, and I put a dot there. Generally, do I know where this is going? Is it going up here? No, that'd be sine. It's going out here because it's cosine. That's where my answer is generally going to be, yes. So what is the angle measured on the top one there? Yep. So then I'd put 30 right here. Now I find cosine of 30. And then I times it by 2. Cosine of 30. Cosine of 30 comes from here. Cosine of 30 was root 3 over 2. And then I times it by 2. So you're putting the angle in here, finding the cosine of the angle, and then timesing it by 2, and then putting the answer here, which again came out to 1.7 on this first one. Yes? Yes, it's going to be a lot like that. That's what you have to know how to do. We're not going to make it super brutal. These are hard enough. Okay. Now, you're not just doing number 1, but there's not too much more. I want you to also do this one. Do you get it's a system of equations? If r equals 2, can't you just stick in the 2 where r is? Yeah. And then, am I done? No. Trying to find where 2 graphs would cross. This would be a circle that has a radius of 2. This, generally speaking, the sine graph kind of looks like this. Do you get that they might intersect? Do you get that they might intersect twice? And therefore, what I'm trying to find is these spots, like here, which is an r comma a theta, and here. I'm not saying that the red one is exactly the right picture of this graph, but I'm trying to give you the big picture of what you're trying to find. So once you stick in r equals 2, now you have 2 equals 1 minus 2 sine theta. If you can't solve that and find that answer from circle trig, then you didn't learn circle trig well enough the first time. That was a really big, important chapter. If you still don't get circle trig, come in the morning tomorrow. I can help you get circle trig down. Because if you can't do this, you don't know how to solve this and get it down to like sine theta equals a half, and then solve for the 2 spots where that is, where sine positive, and therefore it must not be here and not be here, and you got to draw your triangles and stuff. If you don't know how to do that, ask me. I'll help you. All right, I've only given you 2 homework problems. 2. Just 2. That's actually less than the other hours, but I did not give you much time at the end. Okay, so you have 2 homework problems for tonight. Do them, check them, come back tomorrow, and practice some more. And then the test still isn't after that. We have 1 more day of review after that. Tomorrow is mostly review. There might be a spillover of 1 topic into tomorrow, plus review. All right, that's all I got for you for today.